Today we're going to be going over 5.3 and 5.5. And yesterday or last week's lesson in 5.2, because I know we're kind of going out of order, we started basically proving how triangles are congruent. And in that lesson, we had to show all 6 parts were congruent. So if we think about a triangle, triangles have 6 parts, which means they have 3 sides and they have 3 angles. But the nice thing is we technically do not need to show all 6 parts. We only have to show 3 of the parts. Now, if we take a triangle and we take all of the different combinations, so let's say we take a triangle and we take combinations of 3. We could have 3 sides, so side, side, side. We could have 3 angles. We could have angle, angle, side, okay? Now we want to think about the other combinations that we could have. Well, if we think about sides, what if we had 2 sides? So what if we had 2? So 2 sides in an angle. Now, this combination could be done this way, and it would still mean the same thing. But because of what this spells, we typically don't write it like that. We usually write it in reverse. So this is one other combination. Or what if we have 2 sides, so we still have 2 S's, but the A is between them. So it would look like this, side, angle, side. And then the question down here says, does it matter if the A or the S is between? And the answer is yes. So if you look at this combination, so if we look at side, angle, side, verse, side, side, angle, basically what that would look like is, let's say you have a triangle, and let's say I label a side of 5 and of 4. Then the angle that they're going to give you would be physically between them. Now, let's just say this is like a 20-degree angle, okay? So do you see how the angle is between the 2 sides? We call this included, okay? So when it's in the middle like that, we call that included. When it's not between them, so see how it's on the outside, I'm going to draw you the similar triangle, as best I can, looks a little bigger, and then I'm going to put a 4 and a 5 here, but now the angle would not be physically between them. It could either be up here or it could be over here. It really doesn't make a difference. So how about let's put it like right here. Let's say this was your 20-degree angle. So this now, if you look at it, the angle is physically not between the 2 sides. So that's why we write it on the outside. And again, it could be written the same way like this, but because of what it spells, we typically don't write that on our paper. But this is called included, and this is called a non-included. Now, that would be the only way we could do this with sides. So we have 3 sides, and then we have 2 sides, and then 2 sides, okay? So let's look at angles. We've got 3 angles. What if we do 2 angles? So what if we put the 2 angles first? Now, yes, you could reverse this. So yes, you could say side, angle, angle, but because it doesn't spell anything funny like the one up here does, then most people just keep it alphabetical. Then what if, again, if we have 2 angles, what if we put the side in between? So angle, side, angle. And again, I can show you the difference here with those as well. So if we look at angle, angle, side, verse, angle, side, angle. Okay, so if I try to draw 2 of the relatively same type triangles, again, it doesn't really matter if you draw them acute, obtuse, it just matters, just try to draw them kind of the same. Let's say we pick 2 angles. So I'm going to pick, this one is like 40 and this one's 50. This is 40, this is 50, okay? If the side is not between them, it would have to be one of these 2. So it could be like, this is like a 3. So do you see how it's angle, angle, side? Or it could be over here, and it could be side, angle, angle, but it's not between them. Notice this one, again, is called included. It would have to physically be between the 2 angles. So if this is at one angle, and this is the other angle, see how it's physically between the two pieces. So again, this is called included versus non-included. So up here are all of our combinations that potentially could exist. So if you notice, we have 6 different possible combinations that potentially of 3 that could work. And so what I want you to do is I want you to do this little exploration to see how these properties actually function. So if you're at home, you're going to probably want to either type this in, or if you go to the online notes, you can just click on it. It's a hyperlink and it'll take you right there. But I'm just going to kind of demonstrate and show you kind of what it looks like. So when you go to the website, this is what it will look like. And then if you notice, there are 7 different activities for you to go through, and we'll talk about why there's 7 but only 6 combinations. So you're going to click on the first one, and you're going to basically try to make the triangle. So notice what they're giving you is 3 sides. So you're going to try to make this triangle. So I'm going to shorten this, if I can, shorten this to make it to a 6. I'm going to shorten this to make it to a 4. And then I'm going to shorten this one to a 5. And once I get them to the right lengths, I'm going to try to make my triangle. And when I do this, do you see how it kind of turns a yellowish brown? That means the 2 triangles are congruent. So then what you're going to do is once you've done that, you're going to go to your paper here, and you're going to say, will the triangles be congruent? So I would say yes, and then I would say side, side, side was the parts that I used. So you're going to pause the video here, and you're going to go through all 7. So there's 3 on the front, and then it kind of rolled onto the back there. So go ahead and pause the video here and try those. Okay, hopefully you've paused it and tried them. I'm not going to go through all of the explorations, but I do want to try the second one with you. So I'm going to go through this one. And if you notice, I got to do 3 angles. So if I get my angle 45, and if I get my angle 60, now what I want you to notice is, what if I did my sides really like longer? Like, what if I took this and I made it longer? Do you notice that I have all the right angles here, but do you see how my triangle is physically bigger? Now, if I manipulate this, I probably could get it to work. But do you see how I still have the same angles, but yet my triangle is bigger? So when I go back to my worksheet here, it says, will the triangles be congruent? And the answer is really no. They don't necessarily all have to be congruent. So this property, AAA, is not necessarily the best property to use, okay? So hopefully you explored them, and if you need to at any time, you can pause the video here and you can go back and you can try it again. So on number 3, I got this to be a yes, and this was side angle side. And again, the angle was physically between the 2 sides. And then if we look at the 4th one, I also got this to be a yes, and I got this to be angle side angle. Number 5, I got to be a yes, and this was angle angle side. So again, if you notice the difference here, the S is between it where the S is not. And now number 6 is kind of the hard one. So I want to show you number 6. Now if you look at number 6, this is really the swear word because you have S, S, A, or if you want to go A, S, S. So let me see if I can get this to work. So if I change this to be a 7, and I change this to be a 5, and I make this at a 45-degree angle, could I go like this? Come on, stay at 45. Sometimes it's a little touchy. You got to kind of, get them just right. Come on. Well, let me grab that one. I was trying to grab it. You see how I'm kind of inch by inch here. Sometimes it takes a little bit, but that's okay. Oh, I'm so close. Maybe right there. Oh, look at that. Do you see these two triangles? I have all of the requirements. I have angle, I have side, and I have side. But do you see how this one is slightly smaller? Now, if I were to take this side and I were to, angle it, now I could get it to be exactly the same. And see, I can kind of put it over top and it matches. But remember, if I can get it back to that other one, I wish there was a way to like hit a save button, here. If I can kind of go back here, I like how it turns brown when you know you've got it, but sometimes it just takes a second to be able to angle it just right. Come on. Well, you saw it before. If I can't get it to be angled just right, maybe I can go a little shorter. There we go. I didn't have the right size. Do you see how this is smaller? Okay. So this property, what I like to call the swear word, only we're going to write it in reverse, really doesn't work because there is potentially more triangles that could exist. So then we don't really know if they're congruent. But now if we go to number 7, so if you might have noticed number 7 was really similar. Notice this is also the swear word, but look at that angle that they gave you right there. So because of that angle, because it's a 90-degree angle, and because of Pythagorean's theorem, then there's actually only one way we can get this to work. So I just have to make sure, oh, sorry, this side down here was a 5, not a 6, so I just have to switch that. There we go. I didn't notice that one at first. Okay, I want this to be a 7, and notice, boom, now my two triangles match. But if I tried to do anything else, like if I try to angle this a different way, notice there's no way it's going to form a triangle. So what I wanted you to notice here is, yes, this one works, and it's technically the swear word, only it's a 90-degree angle. So because it's a 90-degree angle is the only time that this property actually works. Instead of calling it SSA or ASS, they call it HL for hypotenuse leg. So if you look at this, we have the hypotenuse and we have a leg and we have a 90 degrees. So that's why they call this one HL instead of the swear word. So down here it says, what combinations of 3 form a triangle? So from our chart above, we got side, side, side to work. We got side angle, side to work. Those were from the front. If we look over here, those are the 2 we got. Remember, AAA does not work, so maybe we can list that in. Which combinations do not form triangles? AAA does not form a triangle. All right, let's look at the back side here. We got angle, side angle to work. We got angle, angle, side to work. And then it's the swear word. So basically, the swear word one does not work. It only works if you have a 90 degree, and so they call that HL. That's the only time that property works. So when you're doing the rest of the questions down below, numbers 4 through 12, and they ask you to state the property, they're looking for one of these 5 answers, okay? So I'll try a couple with you, and then I'll pause. You can pause the video, and then you can try them by yourself, okay? So if you're looking at number 4, and hopefully you either have it in front of you, or maybe you have it pulled up on your screen, because I know they're a little bit small. Notice we have some angle marks. We have 1 here, and we have 1 here, and we have 2, and we have 2. So right now we have 2 angles. We do not want a 3rd angle because that's a bad property. We need a side. And so from chapter 4, which I know we kind of skipped, but that's okay. In chapter 4, we kind of talk about maybe either rotating this triangle or reflecting it. But if you notice, this angle has 1 mark, this one has 1. So we would have to take this triangle and kind of rotate it around. But wouldn't you agree that they share this side? So because that side is shared, we call it reflexive. Now the reflexive property is going to become our new substitution. Reflexive is one of the most commonly used properties, and it's used when the triangles are touching. So you see a lot of these are touching. When they're not touching, then we do not use the reflexive property. So the reflexive property is like you're sharing it. Now, because the side is physically between the two angles, then I need to squeeze the side between the two letters. So then this would be my answer. Now it says state if the two triangles are congruent. I guess I should say yes. But if I see this property, then I'm assuming you're saying yes because that property tells me the triangles are congruent. So how about I'll do another one with you. Number 5, I'm noticing 2, 2, 3, 3, and then I'm also noticing again that this is reflexive, so it's shared between the two. And in this particular case, we can probably fold our paper over and it matches. So we know this side is shared. So I would say yes, the triangles are congruent, and I would say by side, side, side. So I have side, 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 side. So this would be my property. So why don't you pause the video here and see if you can try the remaining 7 questions to come up with those, if they're congruent, and to choose one of these 5. Okay, hopefully you pause the video. If you look at number 6, I would definitely agree that this is your reflexive piece. So this is reflexive here, but we got to be very careful. Let me draw this top triangle. So I have 1, 2, and then I have an angle. Now notice we do not know if this is 90. It surely looks 90, but we don't know. So if you look at what's given, you have side, side, angle. So do you see how the angle is not physically between them? So what property you have here is you have the square word. Now, these triangles definitely look congruent. But as you saw in the exploration, there's actually another possibility of this one of these triangles. So we cannot say for sure that these are congruent due to the property that they gave us. Now, if you say no, you don't have to list the property. But I'm trying to explain why it's a no. Now, had the triangle been marked maybe like this, so you have 1 and 2. Had this been a 90, I would have said yes, HL. Had this angle been marked down here, I would have said yes, side, angle, side. But it's due to the location of the angle of why I'm saying no. All right, take a look at 7. 7 is very similar to 6. Notice you have reflexive. And if I draw one of these separate, I also have the square word. I have side, side, angle. But because my angle is 90 versus up here, we didn't know the angle, I can say, yes, these are congruent, and we usually call this the HL. Now, if you put the square word property, I would give it to you because it technically is SSA. However, they don't like to write that, so they're going to put it as HL. All right, number 8, notice there's not a reflexive in this. A reflexive means you have to like completely touch each other. But what we do have is we do have vertical angles. We do have vertical. So when I look at this, I have angle, 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 angle. So I'm not disagreeing that there's not 3 angles, but in the exploration, we saw that doesn't mean the triangle sides are going to be the same length. So I would say no, these are not congruent. All right, take a look at number 9. Number 9's got everything marked for me. I just need to figure out like where everything falls. So it doesn't matter where you start. You can start wherever you want. Angle, angle, side. Angle, angle, side. See, what I'm noticing here is the side is not physically between them, but it's the same in this. So if you were to take, let me grab a piece of tracing paper. If I was to take a piece of tracing paper and I was to put it over top of this triangle, would I be able to turn this triangle and have it match? And the answer is yes. So I would say yes, these are congruent by angle, angle, side. Now again, if you want to say side, angle, angle, you can. It's the same property. It's just, again, most people put it in alphabetical order. Okay, if you look at number 10 is kind of similar to 8 in the sense that we have vertical angles. But the thing that's different from number 8 is they gave us this side. Do you see this tick mark here? So when I look at this triangle, I have angle, side, angle, which is different from up here. And then this one I have angle, side, angle. So I would say yes, these triangles are congruent by angle, side, angle. And again, if you put tracing paper over top, and it doesn't matter which one you trace, here's my vertical, here's my tick marks. If I were to hold this down, I should be able to spin this and it would match up and it would land on top of the other triangle, okay? All right, number 11, if you look, you've got all side, 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 side. So I would say yes by side, side, side. Number 12, again, very similar to 10, very similar to 8. But if you notice, I've got some side tick marks here. So see these tick marks? That's really helpful. I still have my verticals. So if I look at this one triangle right here, I've got side, the angle is right between them, and I've got a side. So I would say yes by side, angle, side. Okay? That concludes this lesson. Now they're really again, we're doing multiple lessons together, but what I wanted you to get today was just the properties. And then the second part of this, so see how it says part 1? The second part of this is going to be actually formally writing the proofs up. So that's what we're going to work on tomorrow. But that concludes the first part of the lesson.